Hello and welcome to tutorial 8 of Let's Learn C for Beginners. So in this video I will explain the differences in libraries, what a library is, and then I'll show you how to use them on Linux and on Windows. I'll provide two examples. One will be creating a GUI or a window application for Linux and Windows, and then the next will be using a header and module library to demonstrate how to use some common dialogues, as in like pop-up windows and stuff, on the various operating systems. So the libraries that I'll be using, they are cross-platform, so you can use them on Windows, Mac and Linux. I think some might actually work on other machines or other operating systems as well. So let's go over what I'm going to cover today. So I will cover what libraries are and their types, and then I will show you how to use two different libraries. So first off, let's go over what libraries are. So libraries, in essence, they're just like a collection of functions and structures. So once you've gone so far in programming, eventually you'll come to a time where you have certain functions and structs that you use everywhere all the time, and there's very little you need to do to change the code on these, as they are almost to perfection for what you need, say. So when you get to this state, rather than continually including these headers and modules every time, you might want to turn them instead into a library. So you can, in essence, you can think of a library as just a collection, a useful collection of code, which you group together, and then you can refer to this as a library. There is a bit more to it than that, as once you've decided that your functions and structs are going to be a library, you would generally then come up with some sort of naming convention for them. But that's aside from what I'm going through here. You'll see this when we use libraries, if you've not used them already. So the idea of a library is to basically create a collection of reusable code. And then one way to do that is to compile these libraries into what's called a static library or a shared library. So by compiling them, you turn them into kind of like an object file. If you've had a look at your sort of your source code, so if I jump into a program a minute, so you'll see when you generate anything, you get a folder with .obj on it, and then if you look in there, you'll see various files with .o after them. What they are is they are compiled code, basically, that needs to be sort of connected together by the linker to form a cohesive program. As all the object files are, is they're sort of compiled, so they're turned from C code into assembly language, and they are just waiting for the linker to basically string them all together into one cohesive runnable program. So you could pass libraries around as object files and a header file. although that's not normally the way you would sort of do things. So a static library usually has like a .a at the end of it, and then a shared library, depending on the operating system. It can be like a .so for Linux. I think that might be the same for Mac as well. I'm not totally sure. I haven't been on a Mac for a while. And shared libraries on Windows are dynamic link libraries. But I'm not sure whether the dynamic link libraries are Microsoft specific. They're basically shared libraries anyway. And the reason why you would, why you compile them, one reason would be that you wish to keep them secure, the code secure. You don't want other people adding stuff to your library and then claiming that you did it, or copying all your code and claiming that they did that. Also, by compiling it first, it means that once a user adds it to their own code, it will not generate any sort of additional compile time when the user uses that library. So the differences here, so shared libraries, they are kept external to the user's code and connected at runtime. So if you use Windows, loads of programs you'll usually see, like a game or whatever, they'll have like various DLL files with them. Those are external libraries which are linked into the program at runtime. So when the program first starts, the first thing it needs to do is it needs to connect to those local libraries before it can run, because obviously there's various functions inside those libraries which the program needs to run. If you've updated versions of Windows, you'll frequently find that old programs no longer run, and it says like a DLL file is missing. And that's because as Windows went forward, it decided to throw out loads of its previous code. So it deliberately doesn't distribute some of the older DLLs with the modern versions. This then prevents your programs from being able to run. Sometimes if you were to re-download that DLL and put it back in place, the program will run perfectly fine. So that's an example there. With I don't really have many examples of Linux, as I haven't really used it for long enough. I certainly don't play any Linux games. I code on Linux, which is what I find it to be best for. However, I think most of the libraries are stored centrally in various places. So you've got like I think they go in user, and then there's like libraries, and then there's I think in loads of these you'll find the .so files. Yeah, here you go. So these are shared libraries here. Anything with .so on it is a shared library. So I think these all need to be they need to be sort of like registered first with the operating system before you can sort of use them. Loads of times when you download a library, this is kind of all done for you in the background. So the idea is that the shared libraries are normally on Windows. You would package these libraries next to the actual program. Obviously, on the older versions of Windows, the DLLs were generally just downloaded and put in like a central resource, just like they are on Linux here. And then static libraries. The difference with these is they are pre-compiled, just like shared libraries. The only difference is that you link them in at build time. so they then become part of the executable. The upside of this is it's obviously less separate files to get lost when your program is distributed, and it's also something less to be sort of hacked, or you're not at the mercy of like an external library. So for example, if a vendor of a library that you used for whatever reason decided to break backwards compatibility, it could be that you might not be able to run your programs going forward if someone unwittingly updated the shared library. So that's something to sort of bear in mind there. Like, whereas with the static libraries, you when you build your program, these are added into the executable, so the end user has no idea about the library at all, as it's added into your program. Again, the benefits of it is obviously no compile time for you, as the static library is already pre-built and distributed with a header, just like the shared libraries need to be. And then there are also other library types as well, which are just as useful. So one reason for preferring header-only libraries or header and module pairs, which are passed to you in this form, is you actually get to see the code inside, so you know that there might not be any malicious code, because potentially you can have a look through it. Obviously this is nice for open source stuff, and the TinyfileDialogs library, which I will go through in a moment, is an example of that. One other useful header-only file is the, I think it's the STB image. Where is it? I think I've got some programs here for converting graphics, and I've got a load of programs here which convert PNG files into image data for the Mega Drive, Super Nintendo, etc. And these use this header-only library here called STB image. And what this header-only library allows you to do is it allows you to work with various image files, so you can load them. It does the loading for you, and it allows you to just extract the raw pixels. So you can create PNGs, load them, and then work on the data here. So this is just an example of a header-only library there, which is pretty useful. Another one which is useful, which I found, is a sound one as well. Let's see if I can find that in a minute. I won't be going through these. These are outside of the scope of this video. I'm just mentioning them here. So where is it? There's one in here for audio. Where have I put it? Sure, it's in here. In fact, it might not be in this folder. So loads of stuff I've coded or used is the SDL library here. Where's the other one I want to quickly mention? So this is the name of it here, Mini Audio, and then example in here. No, I don't know. Anyway, this is the file here. There's one called mini audio, which is a header and source file pair, which is pretty useful as well. So I'll go over the TinyfileDialogs library first. So the link to it, you can find it below, but this is the official sort of page you come to, and then when you download it via the download box here, you will be presented with a zip file, and this is everything you need is in just these two files here. So you literally just drop them into, or basically you copy them into your own sort of program, and that's it. When you build your program, they get included. So what it also allows you to do is to see how they did it, which is very useful. Whereas lots of the bigger libraries like SDL, depending on what you get, well, that's not entirely true. Some you have the option to download the source code for SDL too if you wish, but some of them don't actually provide you with a source code, so you can't actually see how they did it. You just have a header file which describes how you sort of use it. So anyway, let's go over the TinyfileDialogs library here. So it's supplied as a header file in a module. It's a cross-platform, which is nice. What it actually provides you with is a small library that allows you to use various system dialogues using only a single function. So the one function you would use will work on Linux, Mac, and Windows. And the benefit that has is it means you don't have to dive into the various operating systems specifically to find how you would create that dialogue if you were to reproduce what the TinyfileDialog provides for you here. So a dialog is just like a mini pop-up window, or a program like a text box, input box, or a color picker. They also have like open file or save file box, which is useful as it allows you to you can sort of like navigate the file structure of that operating system, and the dialog will provide you with a full path that you can then use to open a file from or save a file to. And I already said that, yeah, you would need to know the individual function names on each of Windows or Mac or whatever to create those dialogues. So what I'll do now is I'll first show you this running on Windows, and then I will show it running on Linux. It's pretty much the same way to use it on both of these, except with Windows you have to link in these to external libraries here from the operating system. This is mentioned in the header file of TinyfileDialogs. So first off, all you would do is you download it from here. You then end up with a zip file which you then extract, and then I would say just put this somewhere where you can reuse these over and over again. Check out the readme file here for a load of info. They've got some provided some wide char types here if you're working with Windows and you need to sort of use those. So first off, I will jump over to Windows. So here we are. So I have an example ready for us to use here. So all I did was I unzipped this. So you can think of this as like a downloads folder here. And then you just copy these. Zoom in a bit here into whatever sort of program you need. So I'll show you an example in Codeblocks. So this can work with either GUI applications, so that's ones which create windows, or with console applications. So this is basically a bare bones console application here. So what I'll talk about first is how you work with this library here. So when you create your new project, you need to go to Build, Project, Build Options, and then make sure you have your application selected at the top of this list here. Go into Linker Settings, and then add in TAC-L and then COM DLG32 and TAC-L OLE32. So what this is doing here is this is telling the linker, which is responsible for basically bringing in all of the external files with your program and combining it into one executable. This tells them what libraries to add in here. As these are system libraries, the linker will automatically find them, as Codeblocks basically has some sort of path already set up in the background to enable system libraries to be found automatically. And then you'll see here, this is the main program here, but there's not a lot to it here. I'll zoom in here a minute. So you see there's not a lot here of, you basically add the header of TinyfileDialogs and the source file. So you can do that by just right clicking on your project and then clicking Add Files recursively. What this will do is this will then pick up any additional files. So this is my Codeblocks project here. Select the folder and then it will automatically add in any additional C or H files. Anything else you want to add in here you can tick. This then adds these in here. So what I have here is I'm using the color picker. So what I'll do is I'll just run this a moment so you can see what's actually going on. Also, they provide a beep function here as well. So all of the function names, you can find various information out in the actual header file of the TinyfileDialogs here. And then here it gives you a list of the function names here. And it also tells you a bit about what each of them do. So the one word they're using is beep, which obviously just makes a beep sound. on each operating system. And then there's like a pop-up window there, a message box, an input box there, and then it tells you what you need, and then it says what you can sort of pass in here. And then you see here is a save file dialog, open file dialog, select folder, color chooser. And these are the main dialogs here, which will be useful in any sort of application where you wish to convey something to the user, whether that be a console application or a GUI or Windows application. So if I run this here, so here we go, here's the color picker here, and then you can interact with it as normal. So for the demonstration here, what I actually do in the program is this color which you pick is obviously returned, so it returns the red, green and blue bytes. I don't know if you heard that. That's a load of beeps that I was doing there. And then you'll see here, this is the color that it returns. So we've got red, green and blue in hexadecimal there. And then a message box here is the next example here. And then there you go. It returns the message that you typed in. And that's it. This is just in these few lines of code here. So the color picker function here, if we side by side these a moment, so if we come down to the color chooser, you see it requests a title which it gives to the dialog. You can then pass in a default color value if you wish. As a load of chars or a string. And then there's another option here for passing it as free chars. And then you have a number of ways that you can kind of get the output from this. So it returns a char pointer. And it also will return the result in the passed in char array here as well, as it describes here. So in this case, all I did was I created the U8 data type here. So this is our color out value here. And then I also created a char pointer here, which is what I actually use in the end to output this. In fact, no, I don't know. So you could use the char pointer here if you wished. All I did was I provided the color out here, and then the return value was stored in 3 bytes here. And then you can see that I print these out in hexadecimal format here. So 2 bytes for each of these in hexadecimal. And then all I did here was I did 10 beeps. So what I did was call this function here, and then put in a little delay there of 1,000 ticks. And then at the bottom here we have a char pointer. So what you would do is, so another thing that the TinyfileDialog will do here as well, the input box, it can be a password box as well. So if I come up here a minute, so you'll see here, if you pass null as the default input, which is this one here, if I pass that as null and then we rebuild that, so you'll see here these values here, 64, 32 and 128, these are the default color which I passed in here. So we will just pick any color here, we're not interested in that. That's the beeps. So our input box should appear now. And you'll see that because we passed in the null there, it's now like a password protected one where you can have the input blanked out. And you'll see here, this is what I typed here, my secret. So that's the example of using the TinyfileDialogs here. Let's create another one. We'll go for a message box here, so I'll comment out all of these in a moment. So let's create a message box here. So you'll see the message box here. So let's go for a message box here. So you'll see here we need a title and then a message. So what is the dialog type here? So in the dialog type here, if we have a look at that, you basically pass in this text line as the option there. So we'll just go with OK here. And then icon type, go for error. And then for default button, we'll just go for 0. And then it has so it gives you like a return value. So depending on what button the user presses depends on what the value returned here is. So here you go. Here's our message box here, and then the only thing you could press there is OK, basically. So 1 was returned there, which was OK, yes. So we'll go for another quick example in here. So we will go for yes, no, cancel. And then let's change it to warning as the type here. And then we'll leave that as 0 there. So we'll save that and rebuild. And now we have yes, no and cancel as options there. So let's do no. You see value 2. Run that again. Cancel. Value 0. And then yes is value 1. So that's an example of using the message box type there. So let's create an open file dialog next. So this one's a bit more in depth here. So you see we need to pass a title here and then a default path potentially, and then the number of file patterns. So basically this here needs to be a const array basically of strings. So for example, I think this is what we need here. And then you would do like a .png, .bmp, I think this is what it's, yeah, here we go, look. Okay, so it's star. So what this will do here is so this is what it will type in here. So you provide something with a list, a string list basically of your pattern types, and in this case we would have our pattern count would be 3, and then what it will provide at the end is basically a string list potentially. So I do have example programs where I actually have this all working here, so I'll try and get this working. Here, so we will do the open file dialog, so call it image loader. Let's move that across a moment, and then we will pass in null as the path, type count as our pattern count, and then pass in that there. and then we will so you see here 0 or 1 for allow multiple selects. So we'll go with 0 here. Let's see if that works. Here we go. So this is our, so you'll see here image files is down here. Doesn't look like it's picked up the image types for us, or maybe it has. Let's go in pictures. Do I have anything in here? So it's found that, so let's see what happens. There we go, and it's provided us with the full path there to that file. Okay, so that's an example of that one there working. And then basically the save file one is the sort of the reverse there. So as you can see, it kind of expects the same sort of things there. And then I'm guessing it will provide you, I think it provides you with a path and the file name that you actually type in here. So we will, yeah, let's do that quickly. So we'll call that image saver. And then default path or file. So this would be, for example, if you wanted this to be locally to your program, then that's where var args would come in. Or sorry, if you had the argc and argv, for example, then you could pass as the default I've not got the C string code here. Basically you could pass, we'll put that in there anyway, pass that in there as the default path. We'll use the patterns again, and then what's that, single file descriptor, and we don't need the 0 there. I think that's right. So let's save that and run. Here we go. So what this has done here is the name it's picked up is the original name of the executable here, so obviously we wouldn't want that. So we'll just put in an example there. So you see the path we passed in is the actual executable path here, and then you'll see the name it sort of returned here. It automatically picked the top of the file type for us here. So this, using that file dialog, you could then save something to this location here. So hopefully you can find uses for that. It's a very useful library, the TinyfileDialogs there. So I'll save this and I'll quit this now. and I will now return back to Linux and do the same. So I'll just pause that a moment. So let's jump into the program on Linux. So it's basically exactly the same. The only difference is obviously we don't need to link in the Windows additional libraries here. So the code's exactly the same. I won't go over all of the examples again that I just did, as they're exactly the same. I'll just show you this demonstration working here. So this is the default color picker here on Linux Mint. So you select a color here. So I'll pick a color there. There's the beeps. And then here's the message box here. There's our returned color, and there's our message. Exactly the same. So everything would be exactly the same as what I just showed you in Windows there. So there's no real need to go over that again. So a very useful library, that one. So that was the TinyfileDialogs library there. So obviously we don't need any additional libraries added for Linux. So now let's talk about the SDL2 library. So this library here is a more in-depth library, and this basically allows you to interact more with your host operating system, and it provides a cross-platform way of basically creating Windows applications or GUI applications and games, and it handles creating Windows or the main dialog, if you like, and it then listens to the operating system's messaging list in the background. So every time you use a mouse or you type something on the keyboard or move a window, resize a window, anything like that, all of these are messages which your host operating system needs to receive. So anything to do with input from any device, your operating system receives that. So think joysticks as well. And SDL2 enables you to work with all of these in a cross-platform manner. And I provide a link to this page here, and the reason why I come to this page here is because I'm working with SDL2. SDL2 is not the most recent version, but it's the version that I know and have been using for a while. Obviously it's still useful as well. You can still create cross-platform games basically on all the operating systems. So to work with SDL2 on Windows, we need to download a development version here. So if you are using MinGW and Codeblocks like I am, then you'll want to download one of the MinGW zips or the tar.gz here. If, however, you are using Visual Studio and you are using Microsoft's Visual C, then this is the version you will need to download and extract. Now, if you are on Linux, then the easiest way is to use the package manager. So for me, I just typed in, open up a window here, console, and then type in whichever one. So sudo apt install libstl2 dev. So nothing to do here for me, but note that the version that it's actually picked up, I believe, is 2.02, which obviously is not the most recent version. This might be different for you on your flavor of the Linux. And for Mac, I believe the DMG file will have everything you need. Obviously, I can't show you how to set it up because I am not on a Mac. However, the examples I show will obviously work. And then on Windows, obviously you download the relevant zip file. So other things that it actually provides, other than the listening to messages and being able to handle operating system messages, it also provides a way to get at hardware accelerated graphics. So this means we can create an OpenGL context, or a DirectX handle, or a handle to Vulkan if we wished, and that would set us up going forward to create a 3D game or application possibly. It also gives us handles for working with joysticks and audio functions, just to name a few of the things that it can allow us to do. I will only provide a quick example today, as this is our example of using a shared library. So first off, I will show this on Windows. So on Windows, once you've downloaded this, so I'll go to, once you download it, obviously unzip the file. So this is the one I got here, SDL2 Devil 2.311. And then when you sort of go down into this, you'll be presented with two different types that you need here. So i686 is the 32-bit version. So if you're working on creating a 32-bit app, which will obviously work on 64-bit machines, then this is the one to use. If you're just interested in 64-bit, then this will be the one to use. I will be working with 32-bit today. And then all you're going to do is extract those somewhere. So all I did was drop them in C drive here. So obviously in the paths, make sure there's no spaces. So you'll see here that there's no space between 2026 and SDL2. And then in here, what we have is in the libs folder here. These are our various libraries. And then in the bin folder here, this is the DLL we'll be using. And then the various header files are in here. So this is how you would, this is how we'll sort of set up using the SDL2 library here. So I already have a pre-built example. So what I'll discuss first is how to handle all of the linking stuff. So this is all of the code here is in one single file here in the main.c file. So first off, whenever you are using shared or static libraries, we will need to add links for the linker, and we will also need to provide search directories for the compiler. So for our version here, we need to provide min-gw32, lsdl2 main, and lsdl2. So these are for working with Windows here. So this, you obviously, if you're going to be coding in Visual Studio, then you will not need this one here. I'm not totally sure whether you will need these two here for 64-bit or not. I can't remember. And then what we need to do here for our search directories here. So you need to navigate to the folder. So you go to add, and then we need to navigate to the directory where you have extracted the SDL2 libraries. So for the compiler one here, it is interested in the header file, so click include and then select the SDL2 folder. You can either keep it relevant or not. These are both the same here, so we don't need both. And then the linker needs to go to the lib folder here. So if I navigate to that again, so C drive, go to the SDL2 and then the lib folder, and then stop there. So this is keeping it relative here, doesn't really matter which version you choose, as long as you have the library one there and the include one there, and then OK there. Now what you should find now is that you can find this header file here, and then you should be able to open this here, and then it should give you this file here, which will then list the various functions to the library and then give you some info on how you can use them. So before I show you what this does, what I'll do is I will create a brand new program and just show you the starting bit. Just so you're clear how to get started with it. So create a new project, console application, obviously a C application, although obviously SDL2 is will work with C++ fine, but obviously make sure that it's bin release here and these are set up correctly when you create this. Make sure it's obviously GCC compiler if you're in Codeblocks. Obviously if you're using something else, I can't really guide you here. So here's our main here. So here's our brand new application here. So you need to go to Projects, Properties, and then the project build options. Make sure you're on the top one here, and then under linker, tac L min GW32, tac L, and then in caps SDL. I can't remember if it's SDL main or SDL2 main. We'll find out in a moment. There we go. We have these. Now we need to add our search directories. So same as before. So for me, C drive, SDL2, include SDL2, select our folder. I'll show you the full path there. There we go. And then, in fact, no, I won't copy that. You can just copy that and paste that in here, but I won't do that. I'll show you the full setup. So we're going to the lib folder and select that. There we go. So that's our compiler and linker setup. So whenever you are including additional libraries like DLL files, the compiler needs to know where the header files are for that library, so you can find the function names which are in there and the structs. And the linker needs to know where the library is. So this setup here is exactly the same for static libraries. You still need the compiler to find the header files and the linker to find the library file. So if you add any more libraries, then you would just add additional lines here. Now what we should be able to do is type hash include and then sdl2.h. What you might need to do if this doesn't come up is go into reparse current project. What this will do is it will, in the background, Codeblocks will try and find the location of these folders so it can correctly identify these. Which in this case it's now not finding. And then you would do argc and so the SDL2 needs this for its Windows main thing. So let's try this here. So that built fine, so it's found them. And then what this would do here, so all this will do here is this will initialize everything for SDL2 and this will quit. So that failed, and the reason why that failed is what we need to do, as we are using a DLL file, we need to provide a copy of that locally to our program. So if we navigate to the demo program a moment, which is here, go to the bin folder in the release. So here's our exe here, and we are missing the DLL file. So we need to navigate back to where we installed SDL2 here. And then if we copy that and drop that in here, then this will get added when this is run. So we could, in theory, just run this here now, but it will just open and close very quickly. So if I come back in here and we try running it again, you'll see that everything worked fine, and that's because the DLL file was linked into our program at runtime. So this is how you would set up a brand new SDL2 program here. So let's jump into the other one here. So I'm not going to cover everything in here. I'm just going to provide you the source code for it. Once I show you it running, as there is a lot going on in here. So we'll run this here. And here we go. Here's our window application here. And I've enabled maximize, minimize and close here. So if we maximize this, what you'll see is a load of colored cubes scrolling down the screen here. So you can resize this window, move it around here, and you'll see in the console window here, if you resize this, the size changes there. So this is the size in pixels of the full window here. And then if you press the escape key, the program quits. You could also close it via the cross close icon at the top of the window as well. So I'll quickly jump into some of this here now. So to start with SDL, we use this function here, the SDL init function, to initialize things. There's various options that you can have with SDL2. I won't be covering them all here. This is just a quick example of working with libraries. The key things in here when working with SDL is to remember to call SDL quit afterwards. What we have in here is an SDL window pointer and an SDL renderer pointer. As we are getting SDL2 to draw the window for us, we need what's called an SDL renderer. And then basically all I'm doing here, I'll provide some functions to create what's basically a coloured filled box type, where we have a rectangle which holds the actual box shape in pixels on the screen. And then we have a colour for the box and an X and a Y speed. We have an array of boxes here. This holds the size of the window itself. I will not be going over into great detail here, but basically when we are working with SDL, you need it to create a window for you first. Once the window is created, you can then create a renderer the renderer allows you then to draw on the surface of that window. And then you'll see the if you look at this function here in the header file in SDL video here, it tells you the parameters, what you need, what they do, etc. And then another thing you can do after everything's initialized is the SDL event struct here. You pass it to this function here called SDL poll event, and then what that does is for every event in that SDL2 intercepts in the background, we can then check out what they are. So in this example here, SDL quit will be intercepted if you press the close icon on that window. There are also some key press events we can intercept. The one I'm intercepting here is SDL key up, and this is the key I'm looking for here, SDL scan code escape. And then if the window is running, what I do then is I basically color the background of the window with this color here, which is a light blue. So you can draw different shapes on the window with various SDL render functions. But to do so first, you have to set a color. So for example, there is one for so you can draw a line or a point, and there's like a rectangle there. So this is the example for using a shared library here. By all means, if you wish to go further into SDL2, I will point you to a useful site, which is called LazyFoo. So if you go here and then go to his SDL2 tutorials, this will give you a good understanding and walkthrough of using SDL2, as I do not have time to go through that in this video here. So that's how you use a shared library in Windows here. So if I quit that there. So once you've built this here, if you go into the bin release here, and then you click this. So in fact, we'll copy that a moment. So here we go, we've moved that. Now if you run that, so this here now, this is basically a redistributable, so you could send this program here to someone and then they should be able to run it on their own machine, as the SDL2 DLL file is included locally there. So that's it for this demo here. I'll now quickly go over it in Linux. So I think I have the same demo. Yes, I do. So the main differences here. So everything here is exactly the same. The only difference is with the setup here is obviously all you need in the linker here is the SDL2, and then nothing in the search directories here. And this is because for me everything has been installed somewhere in here. So I think it is in user. So you see MinGW here is automatically linked against automatically, so I don't have to worry about that. So SDL2 might be in here. Here we go, yeah. So here's all the header files here. So Linux for me has automatically picked this up. I don't know if it'll do the same in your various version. One thing to note though is the include name is different, but everything else is basically the same here. I am not entirely sure how I would redistribute this to someone though. This is the problem, because everything is stored or configured for me automatically. I would kind of need to provide the user, I guess, with some way to download the SDL2 libraries and install them on their own machine, I guess. So that's basically it for this video. Hopefully it's been useful. The TinyfileDialogs is definitely a great little library, and SDL2 is also really good, although with Linux I've no idea how I can sort of distribute things properly, whereas with Windows I have built programs and sent them to people to test and they work fine. I will leave links to the source code to this video, and this pretty much concludes the Learning C videos. Hopefully you've found them useful. If you have any questions or comments, then please leave them below and I will get back to you when I can. Thanks for watching.